We are excited to take you on a visual tour of our cornerstone project, Rhyolite Ridge, a large and shallow sedimentary lithium-boron project located in southern Nevada, midway between Reno and Las Vegas. It is located 340 kilometers south by highway from the company's U.S. headquarters in Reno. The deposit is on federal land in sparsely populated Esmeralda County, which has a long history of mining and mineral processing, including the Albemarle Silver Peak lithium mine 25 kilometers to the east. Nevada is one of the world's most favorable and stable mining jurisdictions, with a mining tradition that ensures skilled labor and industrial resources are available. The company recognizes that both the lithium and boron to be produced at Rhyolite Ridge have critical properties that are essential to modern life and emerging clean technologies. This drives our commitment to develop Rhyolite Ridge into a core, long-term, and profitable asset as part of our responsibility to the planet. Based on the current resource estimate, Rhyolite Ridge can produce up to 30,000 tons of battery-grade lithium carbonate and 250,000 tons of boric acid per year over a 30-year period, making it one of the larger lithium and boron mines globally. Our pre-feasibility study has demonstrated the very strong economics of the project, with a net present value of $1,819 million after tax and an unlevered internal rate of return of 27.7%. Importantly, the preliminary feasibility study demonstrated the potential for Rhyolite Ridge to become a long-life, low-cost, and highly profitable business of global significance. With over 60 drill holes already completed, the deposit is well-defined but still open to further expansion. It occurs as a thick, coherent, and laterally continuous tabular-like body. Based on current drilling, the deposit is estimated to contain the equivalent of 4.1 million tons of lithium carbonate and 10.9 million tons of boric acid. This can be divided into two distinct parts: a lithium-boron portion, in which the rock is dominated by the boron mineral serlicite, and a lithium-only portion in which the rock is dominated by clay and contains no boron. The higher-value lithium-boron portion is estimated to contain 1.1 million tons of lithium carbonate and 8.6 million tons of boric acid. It is the lithium-boron portion depicted here that is the focus for the company's proposed development. The lower-value lithium-only clay-rich mineralization will be stockpiled for possible future processing if and when economic processing technologies are developed. The deposit outcrops along its western margin, and it is this area that will be mined first to take advantage of shallow, high-grade material and thereby provide significant early cash flow. These first 5 stages of the quarry will take approximately 6 years to complete, while the remaining 3 stages will proceed across the estimated 30-year life of the mine. The overburden and lithium-only clay mineralization will be stockpiled adjacent to the quarry. The lithium-boron ore will be trucked on internal haul roads to the processing plant 2 kilometers northwest of the quarry, where it will be stockpiled, ready for processing. The processing plant consists of 4 main components: the sulfuric acid plant, the crushing and vat leaching plant, the boric acid plant, and the lithium carbonate plant. The sulfuric acid plant is the heart of the process, producing sulfuric acid, steam, and electricity to drive the entire process. By combining sulfur prill and water, sulfuric acid will be produced and piped to the leach vats. Heat recovered from the production of the sulfuric acid is used to generate steam that will be piped to the boric acid and lithium carbonate plants to drive the evaporation and crystallization steps in the process and heat the vats. Steam will ultimately be passed through a steam turbine generator to generate electricity. Stockpiled ore will be crushed and sized to reduce the rock particles to no more than 1 inch or 25 millimeters diameter. the sized ore will be loaded into a series of large concrete vats by conveyor. As the ore is being loaded, the vats will be flooded with an acid-water mix and the leach process will begin. After 4 days in the vat, virtually all the lithium and boron will be leached from the rock into the acid solution. The lithium-boron-bearing solution is referred to as pregnant leach solution, or PLS. The vats are unloaded and the vat leach residue, or spent ore, is moved to an adjacent dry stack storage facility. This process means there is no need for a tailings dam. The PLS will then be sent to the boric acid plant for recovery of boric acid. As a first step, the PLS is cooled and approximately 50% of the boric acid is recovered. This will be followed by an evaporation step to concentrate the PLS, followed by a second stage of crystallization to recover the remaining boric acid and remove other sulfate salts. The remaining boric acid is separated from the sulfate salts by flotation. The boric acid will be purified using simple wash, filtration, and recrystallization steps. Lithium remains in solution at this stage, and test work confirms lithium losses are minimal. The high-concentration lithium-rich solution will then pass to the lithium carbonate plant for further removal of impurities by the addition of lime and sodium carbonate, followed by ion exchange. The purified brine will then undergo further evaporation to concentrate the lithium to the point that it can be precipitated through the addition of soda ash. Technical-grade lithium carbonate is produced. To minimize operational risks during ramp-up in production, the company will wait until year 3 to install and operate a lithium carbonate purification circuit that can take the technical-grade material produced in the first few years of operation and purify it to battery-grade lithium carbonate. Rhyolite Ridge is now positioned to become the first major American supplier of lithium and the next major global supplier of boric acid. The project provides not only a substantial foundation for the company to contribute to local and state economies, but also has the characteristics to become a highly profitable and globally significant project producing 2 key materials necessary for a more sustainable future over many decades.